So good morning everyone. So today before going with find the location of any complex number in argand plane, so here I'm discussing again the argument or amplitude. Both are same condition of any complex number. That means you have to find the angle of the particular complex number that is made in argand plane on the positive side of the x-axis. Okay, so if you have condition of argument or amplitude of complex number, like if any complex number z is equal to a plus ib, a represent for x-axis, b represent for the imaginary part, that is your y-axis. So I told you before that to easily find the particular angle in particular quadrant, so first we identify the base angle alpha. So that is mean 0 to 90 degree, that is tan inverse b by a. Okay, so after that theta we call it actually argument of z, that is actual angle of the complex number lies in the argand plane. So if there is a tan inverse b by a, that means theta is equal to argument of z. And I told you if you find the base angle, we can easily find theta, that means argument or amplitude of complex number by applying this rule. If according to the sign it lies in first quadrant, then alpha base angle will be equal to theta. Second quadrant, theta is equal to 180 minus alpha. Third quadrant, theta is equal to 180 plus alpha, and theta is equal to 360 degree minus alpha. So this way we can identify argument of a complex number. But sometimes what has happened, we have to directly identify the argument by applying the values. So if there is a no basic angle is there, like 30 degree, 45, 60 degrees there, that time I told you, you have calculator is allowed in your exam. So you can easily identify tan inverse value of b by a if other than this basic angle is given, like 30, 45 and 60 degree, like decimal is given, like major number is given, you can go with that. Okay, so here is some rules of the amplitude is that if your complex number is 0, so that means tan inverse, that your tan theta will be 0 by 0, that means theta is equal to tan inverse 0 by 0. So in this case, if 0 by 0 is there, so that is not possible, so that is not defined. That means in that way, if there is a no location of a, no location of b is there, that means it lies in the origin. So that means there is a no particular position of the complex number in the plane. If your real part is 0, only imaginary part is there. That means if your complex number lies on only imaginary axis, that means b by 0. If denominator is 0, that is infinite, and tan infinite, tan pi by 2, that means tan 90 degree is equal to infinity. In that case your theta will be pi by 2 if it lies here. If it lies on the positive side upward, that it will be pi by 2, and if lies is downward side where y is negative, your imaginary part is negative, so that will be minus pi by 2. But if what happen, if your imaginary part is 0, only real part is there. Okay, so in that case your theta will be 0, because 0 upon anything will be considered as 0, but it should not be 0 at the downward in that case. Now the value of theta, where minus pi less than theta less than pi, is called the principal value of the argument, that is lies in 0 to 360 degree. So if your thing, because we generally consider as opposite to pi is minus pi, but here we have to go so simple. In simple way we can consider that if values lies in the one complete circle, like 0 to 360 degree, so that we call it a principal value of the argument. Next is there is some rules like log. If two complex numbers are multiplied, and if you find the amplitude, so instead of multiply first and make a single complex number, we can directly simply separate this one like amplitude of first complex number plus amplitude of second complex number, but in this case we have to apply the trigonometric formula to solve the further. Okay, similarly amplitude of, if any there is a fraction of the two complex number, so instead of rationalize and make a single complex number, if we directly applied amplitude of first complex number minus amplitude of second complex number, so in this both cases you have to apply the trigonometric formula. So that will be clear in this question that I already sent you yesterday assignment also. So in this question, if I have a question, a variable complex number z in such that the amplitude of z minus 1 z plus 1 is always equal to pi by 4, so you have to find the location of the complex number in the argand plane. So for finding the location of any complex number, first I need the equation, whether it is an equation of a line, whether it is equation of a circle, so that I can easily place that line or equation in the argand plane. So this question I go with the two methods, first with your amplitude formula and this without amplitude formula. Okay, so if I have a z, so if no complex number is given, so we can imagine we have any complex number that like point is xy that is moving in the plane, and z is equal to x plus iy, z minus 1, z plus 1 is equal to x plus iy minus 1, x plus iy plus 1. So first I equate the real and imaginary with imaginary. This is my exact fractional complex number. So if I go with the amplitude, which I just told you the formula of this, like if I write it amplitude, first I will solve with this amplitude method, then without amplitude method. So amplitude, my formula is z1 by z2, that is amplitude of z1 minus amplitude of z2. Okay, so now according to that, if I apply it here, write amplitude, because if z1 and z2 is there, so I can easily write in this form z1 by z2. So when I apply it here in this complex number, so first I will write it here like amplitude of x minus 1 plus iy, then x plus 1 plus iy. So in your question, so that amplitude of this complex number is equal to pi by 4, that is given in your question. So I will write it here pi by 4. Okay, so next I will apply this rule here, that is amplitude x minus 1 plus iy minus amplitude of x plus 1 plus iy combined form, and on the right side is pi by 4. Now when I open this one here, so according to my amplitude of any complex number, tan inverse imaginary part upon real part, so that will be tan inverse y upon x minus 1, because we ignore I it here because we only pick imaginary part in the numerator and real part in the denominator. Here also tan inverse y upon x plus 1 is equal to pi by 4. And if this is a trigonometric condition is there, then I have tan inverse A minus tan inverse B formula is tan inverse. I am going to directly write the formula. I will write it here. So tan inverse A minus tan inverse B formula is tan inverse A minus B and 1 plus AB. This is my tan inverse A minus tan inverse B formula. So I apply it here. So later we will study about in this formula, but here we have to apply the formula here. So that become y upon x minus 1 minus y upon x plus 1, then in denominator 1 plus y upon x minus 1 and x plus 1 on y is equal to pi by 4. When this tan inverse goes out here, that changes to tan pi by 4. So that become tan pi by 4. And here when you take the LCM of this one, denominator will be same, so I can directly remove the denominator. So that is x square minus 1, a minus b, a plus b, and x plus 1 will be multiplied with y, x minus 1 will be multiplied with this y, negative sign between that, and my required condition will be y x plus 1 minus y x minus 1 upon, so only x square minus 1 plus y square is left. Okay, when you arrange this equation, so when you open this one, xy will be cancelled, only y plus y, that is 2y is left, and tan pi by 4 value is 1. So when I cross multiply this, x square minus 1 plus y square. Okay, so my required equation will be x square plus y square minus 2y minus 1 is equal to 0. So this is a second degree equation. So this is the one method if you're going to apply the amplitude rule. But somehow if we don't remember the formula, so what I will do? So we have another method also, because to make it equation we have two methods. Either I go with this formula, or either I go with the without formula here. So now I'm going to here with the without formula. Without formula means if you have this complex number like x minus 1 plus iy, x plus 1 plus iy, you rationalize it and make a single complex number, then you go further. So if you find the single complex number, then you find the argument of that single complex number. So what I will do, first I will rationalize this one, plus iy upon x plus 1 plus iy. So I will change only this sign, x plus 1 minus iy, then x plus 1 minus iy. Okay, so I'm going to make this as a single complex number converted into, so this is equal to this, because I'm just writing, because this will move to this equal. So here, so this whole bracket will be multiplied by this, like x minus 1, x plus 1, then minus x minus 1 iy, then plus x plus 1 iy, then minus I square y square, and in the denominator will be a plus b and a minus b formula. So that is x plus 1 whole square minus I square and y square. Okay, so when you open this one, this is a minus b, a plus b, so that will be x square minus 1, and this negative become positive because I square value is minus 1, so plus y square, I keep it aside. So when I open this one, like minus x iy plus iy plus x iy, then plus iy, and in the denominator it will be x square, here is x square plus 1, so I keep as it is whole square, so that will be easier for me. Okay, so now what I will do, so this x iy will be cancelled. Okay, so what is the equation left it here, x square plus y square minus 1 plus 2iy. Okay, and in the denominator will be x square plus 1 whole square plus y square. No need to open the denominator, because this denominator is part of this and this also. When you separate this one, like x square plus y square minus 1 upon x, this will be x plus 1 whole square. So this is x plus 1 whole square, then plus y square, then plus 2y by x square plus 1 whole square plus y square I. Okay, now after making this single complex number, now I go with the tan inverse. That is my argument. So if I think that both are positive, that means it lies in the first quadrant, so I can go with directly amplitude of this complex number will be tan inverse. Denominator is same in both the cases, so it will be cancelled. So according to the statement, so this amplitude like imaginary part upon a real part, denominator in both the cases will be cancelled, is equal to pi by 4. So when tan goes it here, that becomes again tan pi by 4. So that is 2y upon x square plus y square minus 1 is equal to tan pi by 4. After that, this equation will be same. So there are two methods to make this equation. When you cross multiply this, because tan pi by 4 value is 1, so x square plus y square minus 1 will be goes it here, then after that this equation will be made. So you have two methods to make the equation. If you are comfortable with the formula, you go with this. If you're not comfortable with the formula, so without formula you can prepare like that. Ultimately I need the equation. Now this is my 2-degree equation. Okay, now if you compare with this 2-degree equation, like x square plus y square plus 2gx plus 2fy plus c is equal to 0. If you look at this, there is no value of x is there, that means g part is 0 and f part is equal to, because if you extract 2 from that, only minus 1 is left. That means f part is minus 1 and c is equal to also minus 1. So now you have to find the center. Center will be minus g and minus f. So that will be center 0 and minus minus become plus, so that will be 0 1, and your radius will be g square. 0 plus f square is 1, then minus c if you want the radius also. Okay, so minus minus 1, that is plus 1 and square root, so that will be root 2. So root 2 is the radius, center of the circle is 0 1, and this is your equation. Okay, if you exactly want to find the point, first if you make it x0, because we have to find the location of the x-axis of this circle, because center lies at 0 1 on the y-axis, so that means it passes through the x-axis also. So if you make it 0 it here y, so that means x is equal to plus minus 1. So if you show in the Argand plane, so if you try to show in the Argand plane like this, so I just made it here. So suppose this is your 0 1, sorry, this is the center of the circle will be 0 1. I think I have to make it here, it will be easier more. So in this 2D plane, so if you mark it here like 0 and 1, and if you in this equation like x square plus y square minus 2y minus 1 is equal to 0, if y is equal to 0, because it passes through the x-axis, you need the point on the x-axis, x square is equal to 1, then x is equal to plus minus 1. So that means if y is 0, so these 2 points all lies on the circle, so that will be minus 1 comma 0 and this will be 1 comma 0. Okay, so that means this is the radius of the circle from the center to this point, because these 2 points passes on the circle. So that means when you draw the circle, so this will be your required circle. So that is, and you have to find the location of the complex, because this is the radius will be root 2. If you check, radius will be 2, like distance between these two is root 2. Okay, so this is the radius, so this is the center, and point, so point, that means wherever that lies on the boundary. So these are the 2 points lies on the circle. So this way you can find the location. If you go with to check the amplitude also of this complex number, so that will be pi by 4, that means angle will be here, that is pi by 4. Okay, so this way you have to solve this question. And another, I go with quickly with the second part of this one. If you have a complex number x plus y I satisfies the condition argument of z minus I is equal to pi by 4, so how you will find the location of the z? This was our first part of the circle. Now first part. Now second part, if you find the location of this, so you can go directly with this, like argument of z minus a is equal to pi by 4. So first you make it a proper complex number inside, then you pick the argument or amplitude. So that is x plus iy minus a is equal to pi by 4. So that means if you equate the real part, x minus a plus iy is equal to pi by 4. Now what you will do, so this changes into my tan inverse formula. Equate only imaginary part upon real part. So that is y upon x minus a is equal to pi by 4. When tan move on this side, that will be tan pi by 4. Y upon x minus a is equal to tan pi by 4, and tan pi by 4 value is 1, then y is equal to x minus a. So that is my equation. If you look at this equation, compare with this your equation of the straight line, because it looks like this is a equation of a straight line. If you compare with this, so m is equal to 1, that is same as your tan pi by 4. So that is a slope. That means m is equal to 1. That means m is equal to tan theta is equal to 1. That means that is tan 45 degree. So that is the angle. Okay, now you have to find the point at which point it will connected on the either x-axis or y-axis. If you make x-axis 0 here, like x0, at x is equal to 0, y is equal to minus a, at x is equal to a, then y is equal to 0. So after finding two coordinates, now you represent on the line. Like if this is a line, okay, so if any point is there, so it lies between a and minus a. If x is 0, so something point is here, we can consider that y is minus a, that is 0 minus a. And another here, any point is there, so that will be a and 0. So when you join this one, because this line shows that this is my straight line and this angle will be 45 degree. So this is my required answer. Thank you.